Okay, so we just talked about what it means for two planes to be parallel. Well, what happens if they're not parallel? What do we do now? Well, let's draw a picture of the situation and see what happens. All right, so we're going to draw a nice big plane here, pi 1. All right? And now let's draw another plane that's intersecting it. All right? So that one might come out, say, like this. All right, so we can see these two planes intersecting. Right? So of course this one keeps coming out, or going out and sort of down, and the pink plane is kind of coming right out at us. All right, so what do we notice? Well, so the first thing we notice is that the two planes, which let's give the second plane a name as well, let's call it pi 2. We notice that the two planes intersect in a line, not just a point. And that should make sense, right? Think of two pieces of paper. If you kind of want them to touch each other or like go through each other, you're going to see a whole line that the two pieces of paper make. Right? So let's maybe change the color of this bottom line here to a nice green and say, let's call this L. Right? And that'll be the line of intersection. Okay, but that's just one interesting thing. There's more interesting geometry here in this picture. And where is that at? Well, putting my face in the planes here, we can see, look at how these two planes intersect. Right? Just like two lines, when they intersect, they form an angle. Well, if two planes intersect, we can also see an angle right here in between them. And let's call that angle theta. So we can try and find out what is the angle of that intersection there. How can we find that angle? How can we get at that? I mean, we have these two planes here, and planes are very big. There's a lot going on there. Well, let's look at what happens with the normal vectors to the plane, right? The normal vectors are what really control how the plane is tilted. So if we compare the two normal vectors of the planes, hopefully we'll get something useful. So let's see what happens. The best way to do that is just sort of on the plane here, let's say at this point on pi 1, what we want to do is draw in the normal vector. So to help it look like a normal vector, what we're going to do is draw some lines in the plane here, just to help give us some perspective. Right? And then, well, when we draw in, let's use green. When we draw in the normal vector, we'll see, and we see that's perpendicular. Now I want to also draw the normal vector to pi 2 at the same spot. So the normal vector to pi 2 is basically pointing straight up mostly. So let's draw that in right here at this point as well. Right? So that looks something like this. All right. Well, what do you see? Can you find this angle of intersection between the planes with these vectors? Well, the way you can see it is, well, we have an angle here, right there, and we're just kind of turning it, and look, there it is. We found it. It's right here. Right? So the angle between two planes is the same as the angle between the normal vectors of those planes. Well, back in the section on the dot product, you learned how to compute the angle between two vectors. You might remember back in the section on the dot product, we had a way to do that. right? So if you remember, if we take the dot product of the two vectors, we can describe that in terms of the angle between them. It's the product of the magnitudes of the two vectors times the cosine of the angle. And since I have this angle written here in blue, let's just go ahead and write it in blue again. Couldn't hurt. All right. So what we see there is a way we can solve for this angle theta. So let's do this in two steps. Right? First thing we can do is divide by these here, move them to the other side. These had better not be 0, otherwise these aren't very good normal vectors, by the way. So, and I'm going to move cosine to the other side. So cosine, let's keep that blue theta going. This is going to be equal to n1 dot product n2 over magnitude of n1 times magnitude of n2. Okay? So this is the cosine of the angle between the planes, or the angle of intersection. Okay? Well, we can do one more thing. We can actually solve for that angle. And that's just by doing the inverse cosine to both sides. So theta, the blue theta here, let's get rid of that little hat. Okay. So that blue theta, that's equal to the inverse cosine, or arc cosine, of this quantity here, n1 dot product n2 over the product of the magnitudes. All right? And at last, we have our equation for the angle of intersection between the planes, given nice and neat right there.